Critical density. If the density of the universe is greater than the critical density, the current expansion will slow down, stop, then become a contraction. This is what we'd call a closed universe. If the density of the universe is lower than the critical density, it will continue to expand, and we'll have an open universe. At the critical density, the universe would just stop expanding, and this would be a flat universe. I'm now going to derive an expression for the critical density of the universe. You don't need to be able to derive the expression, but you will need to be able to use it. First, let's consider a volume containing all the galaxies. And I'm going to consider one galaxy here of mass m, and it's travelling out with a speed v. Here we have a volume of mass big M, which contains all the galaxies which are closer to the centre. They are in a sphere of radius r. The centre would be the site of the Big Bang. Our galaxy will have kinetic energy given by mv squared over 2. But from Hubble's law we know that its speed is given by the Hubble constant multiplied by its separation. And this gives the kinetic energy by this expression. To escape, the galaxy must gain potential energy given by this expression, where m here is the mass of this region, and that is given by the density of that region multiplied by its volume, and the volume is 4/3 pi r cubed, giving us this expression. We can now substitute this term into here, giving the potential energy by this term, which we can simplify to this. I've copied the final terms for the potential energy and the kinetic energy onto this slide. At critical density, the kinetic energy will be just equal to the potential energy needed to escape. And so we can write this. And now you see I've put the density with a subscript c for the critical density. Rearranging, we get that the critical density is given by 3 times the Hubble constant squared over 8 pi times the gravitational constant. At present, it's believed that the density of the universe is very close to the critical density.